Okay, so in the last class, it was just introduction about the gravitation, and today we will discuss in detail, and the recorded video lecture will be uploaded on YouTube. You can do it again and again, and draft notes according to this video lecture. So, contribution to gravitation goes to many scientists before Newton's, and that was Tycho Brahe, Copernicus, Galileo, Kepler's, and ultimately Newton studied concept given by all the scientists before Newton, and then he compiled all ideas and then calculated and gave adequate law that is now known as Newton's law of gravitation, universal law of gravitation. So let us first be familiar with the topic that we have to discuss in this chapter. First of all, we have to discuss about gravitational force or gravity. Second one is Newton's universal law of gravitation, and third one is properties of gravitational force, universal gravitational constant, and Kepler's law of planetary motion, Newton's second and third law, and gravitation. And then free fall, concept of free fall will be discussed, acceleration due to gravity, and as we have discussed motion and equation of motion in the first chapter. So here freely falling object is also in motion, but here acceleration will be due to gravity. That's why here we have to study again equation of vertical motion or under influence of gravity or gravitational pull. And mass and weight that I have already discussed briefly in the yesterday's class, and then thrust and pressure, pressure in fluid and buoyancy or buoyant force, Archimedes principle and principle of flotation and density as well as relative density. So all these topics that we have to study in this chapter. So let us start with the gravitational force of Earth or gravity. Remember here, gravitation and gravity is different things. A little bit, try to understand what they mean by gravitation. Gravitation is in broad sense, is defined as the force of attraction between any two heavenly bodies with huge masses. Then the force of attraction is said to be gravitation or gravitational force. Now, if you take a massive body, that is say heavenly body, and other object with negligible mass in comparison to that heavenly bodies like Apple and our Earth. If you compare the mass of Apple and Earth, mass of Apple is negligible in comparison to mass of Earth. Yet, attraction between Apple and Earth takes place. So here, a force of attraction between Earth and Apple, or attractive force that exerted by Earth onto the Apple, is called gravity. So there is a difference between gravity and gravitation or gravitational force. So a force is necessary to produce motion in a body that I have already discussed in the previous chapter, laws of motion. First law of motion describes that an object at rest will continue to be at rest, an object in motion, uniform motion, will continue to be in uniform motion until and unless some external unbalanced force applied on it. So it is well known to us. So a force is necessary to produce motion in a body. The same concept was applied by Newton while he was sitting in his orchard during break due to an epidemic disease that was spread in during that time. So the school and college were closed for uncertain period, and then he was sitting in his orchard and studying. At the same time, an apple fall down from the tree to the surface where he was sitting. Then he start pondering. That means thinking that why this apple fall down to the earth? Why not up or dextral side? And then he applied first law of motion that he was already given, and he thought that there must be force acting on this apple. That's why motion has been produced in this apple, and always object starts moving in the direction of applied force. Then he thought that why apple falls down, that means earth must applying any kind of force towards its center. That's why apple comes down. So just let me see. Okay, a body dropped from the height falls towards the earth. It does not move upward away from the earth. It indicates that the earth exerts a force of attraction called gravity on the body. So, in fact, the earth attracts all objects towards its center. That's why you see that everything falls down to the surface of the earth. A flying aeroplane, when its engine shut down or becomes in disorder, then aeroplane fall down onto the earth. You see, and you throw a ball in upward direction. After some times, ball will come to the back to the surface of the earth. As it moves upward, its speed go on decreasing. Why? There must be a force acting opposite to the motion of the ball. So the force with which earth pulls an object towards its center is called gravitational force of the earth or gravity. The gravitational force between sun and earth keeps the earth in uniform circular motion or elliptical path around the sun. It is gravitational force. So you see here, if you treat it as a moon, then you will see that earth attracts the moon towards its center. That's why the moon keeps on revolving around the earth. The gravitational force of the earth is responsible for holding the atmosphere above the earth's surface for the rainfall to the earth. You see that at the moon there is no atmosphere because there is no adequate gravitational force acting on the air molecule to keep it confined near about the surface of the moon. That's why there is no atmosphere onto the surface of the moon. And on our earth, gravitational force acting on air molecule or air particles that is exerted by the earth is almost 6 times greater than that exerted by the moon. That's why air molecule cannot escape out from the surface and near about the surface of the earth. That's why our earth has a blanket of air around it that is called atmosphere. So for the rain falling to the earth, even then gravity is responsible for that. You know that due to hot weather, water vaporized at the surface of sea level and rises up and as it rises up, temperature go on decreasing and decreasing. So this water vapor then condenses into water droplets, and gravity act on that water droplets. That earth attracts that water droplets. That's why raindrops fall onto the surface of the earth. So you see rain falling. Now, and for the flow of water in the river, this is also it is also because of the gravitational force of the earth. River flows from high altitude to low altitude. That implies that at higher altitude, gravitational force is a little bit lesser, a little bit lower than at the low altitude, because as one is closer to the surface of the earth, that is closer to the sea level of the earth, much more gravitational force will be acting there. That's why water tends to flow from high altitude to low altitude. That's why river keeps on flowing continuously. And in jail or in lake, you will see that no water is flowing continuously, because in lake water level everywhere are at the same altitude. That's why water does not flow from one part of the lake to another part of the lake. But in the river, it flows from high altitude part of the river to that of the low altitude. So you see that most of the rivers emerge out of the Himalayas and mountain range, which is at higher altitude. That's why these rivers flow from high altitude to low altitude. That is from uh, higher altitude of the mountain to the low level sea level. So all rivers flow into the ocean. Now, now you see, for keeping us firmly on the earth, you see, it is gravity that keeps us upright on the surface of the earth. For the time being, if for even single moment gravity vanishes, we will not be able to stand upright onto the surface of the earth. Next one is for the revolution of the moon around the earth. It is gravity or gravitational force which is responsible for the lunar motion and motion of the moon around the earth, or motion of the earth around the sun. Now try to understand. Gravitational force between the earth and moon causes tides, rise of tides in the ocean or sea. Think why tides are high during during full moon day and new moon day. So uh, during full moon day, that is known in our Indian uh, culture or tradition as Purnima or Poonam. And during that day, gravitational pull becomes maximum between Earth and Moon. So, as water is not a solid particles, a part of ocean get pulled towards the moon during full moon day. So you see that uh, water level a little bit rises up above the sea level normally, and that's why when moon moves to the opposite side of the earth, then this raised water again moves towards the normal position and giving rise to the tides on the sea level. So you see here new moon day, uh, water level of ocean get pulled a little bit towards this one. So this is the reason behind. So tides type is spring. And next one is few fact about lunar tides. This is optional in reading, but if you think in detail, it will be much more interesting. So, okay. And here you see a few fact about lunar tides. The gravitational force of moon is 110 million, 110 millionth that of the earth. But when you combine other forces such as earth's centrifugal force created by its spin, you get tides. The sun's gravitational force on the earth is only 46% that of the moon's gravitational force, that making the moon the single most important factor for the creation of tides. The sun's gravity also produces tides, but since the forces are smaller as compared to the moon, so the effect are greatly decreased or smaller, because although sun is millions times massive than our earth, thousand times massive than our earth, yet it produces weaker gravitational pull in comparison to moon, because moon is much more closer to the center of the earth. And you can say that our sun is almost 15 crore kilometer away from the center of the earth. On the other hand, moon is only up to 23 and 24 lakh kilometer away from the center of the earth. That's why gravitational pull is more effective in between earth and moon in comparison to earth and sun. Tides are not caused by the direct pull of the moon's gravity. The moon is pulling upward on the water while the earth is pulling downwards. So slightly advantage to the moon, and thus we have the tides. Whenever the moon, earth and sun are aligned together, the gravitational pull of the sun adds up together to that of the moon, causing maximum tides. During that time, tides will be high. That is, high tides rises up when moon, earth and sun becomes aligned. That is, the same line in the same plane. Next, spring tides happen when the sun, moon are on the same sides. So high tides rises up. So spring tides are high tides. Or when the sun and moon are in opposite sides of the earth, even then high tides rises. So when हेलो आज नहीं आ पाएंगे, लेकिन कल आ जाएंगे। आज कहाँ जा रहे थे? वहाँ? अच्छा अच्छा, नहीं वो कल हम आ पाएंगे, आज थोड़ा सा व्यस्त थे किस काम में, तो कल हम आ जाएंगे। कल आ जाएंगे। ठीक ठीक। So when the moon is at the first quarter or last quarter phase, meaning that is, it is located at right angle. It is located at right angle to the sun-earth line. Then sun and moon interfere with each other in producing tidal bulge, and tides are generally weaker in that case. These are called neap tides. Weaker tides are called neap tides. Now, offshore, that is away from the shore of the oceans, in the deep oceans, the difference in tide is usually less than 1.6 feet. So the surf grows when it approaches the beach and the tides increases. In bays and estuaries, this effect is amplified. In the Bay of Fundy, tides have a range of 44.6 feet, which is much more greater in comparison to 1.6 feet. The highest tides in the world are at the Bay of Fundy in Nova Scotia in Canada, because the earth rotates in its axis. The moon completes one orbit in our sky every 25 hours, not to be confused with the moon's 27-day orbit around the earth. This is a rotational time period, because we get two tidal peaks as well as two tidal trough. As you have seen in a wave representation, there are crest and troughs. So peaks can be treated as crest, and trough is already known to you. So these events are separated by about 12 hours. That means you can say that after every 12 hours, peak is generated or trough is generated. Since the moon moves around the earth, it is not always in the same place at the same time each day. So each day the time for high and low tides changes by 50 minutes. The types of gravitational force that causes tides is now as attractive force. Now, Newton's universal law of gravitation. So far, we have discussed about gravity and gravitational force and application and significance of gravitational force. Now we are going to discuss the most important topic that we have already discussed about this, its importance. You know well that even your life is impacted by the gravitational force, your blood pressure is impacted by the gravitational force, and your breathing frequency is impacted by the gravitational force. Because if you are suddenly taken to a place where gravity is two times greater than that of right now, then you will feel that you are unable to breathe in or breathe out. Or even a person with heart patient may go or undergo cardiac arrest during that case, because his or her heart is not capable of overcoming the gravitational pull. Because you know that as gravitational pull or acceleration due to gravity increases, blood pressure will increase there. So all these are controlled by the gravitational force. That's why your gene, your living style, and lifespan all depends on gravitational force. So even you can talk about an alien. Alien could be different from you, because on planets where alien is residing might not have the same gravitational pull or acceleration due to gravity as you are having here. That's why alien must be different from you in their body structure and in their lifestyle. Now, come to know now new topic here, which is important and main topic of this chapter, that is Newton's universal law of gravitation. A statement of this law, first of all, to be understood well. Every body, according to this law, every object, even a single particle, every particle in this universe attract every other particles or body with a force which is directly proportional to the product of their masses and is inversely proportional to the square of distance between them. This is the well-known statement of universal law of gravitation. Now, in order to understand mathematical aspect of this statement, the direction of force, here you will see direction of force is along the line joining the center of the two bodies or particles. So, in order to explain mathematical aspect of these statements, universal law of gravitation, let us take out two bodies with mass m1 and m2 separated by a distance r from their centers. Say two body A and B of mass m1 and m2 are placed at a distance of r from each other, and let F be the force of attraction between the two bodies. Then, according to Newton's law of gravitation, the force of attraction is directly proportional to masses of the two bodies, that is product of masses, product of their masses, that is F proportional to m1 into m2. Next aspect of the statement is that how this force of attraction depends on distance. So force of attraction is inversely proportional to the square of distance between them. So you can say that here F is proportional to 1 by r square. So we have two mathematical statement that is satisfying the statement given by the Newton in order to describe a universal law of gravitation. So on combining these two proportional equations, we get F proportional to m1 into m2 divided by r square. Now we have to insert a constant in order to equating force and the quantity on right side. So this proportional constant, capital G is proportionality constant and is called universal gravitational constant. It has numerical value 6.67 into 10 to the power minus 11. Now, this is the well-known mathematical expression for the force of gravitation, an expression for the force of gravitation. This is the magnitude of the force with which the two objects with mass m1 and m2 being separated by a distance r attract each other. So you see that the two objects attracts with equal and opposite force. So you can say that the gravitational law obeys Newton's third law of motion. Now we have to learn about the properties of gravitational force. Gravitational force is the weaker force in nature in comparison to electrical force and magnetic force. It is an attractive force. Gravitational force is always attractive. It is not repulsive. And on the other hand, magnetic force and electrostatic force are repulsive as well as attractive. So, because gravitational force depends on mass, and there is no two types of mass, only one type of mass are there. So one cannot say that two masses can repel or attract each other depending on their nature of masses. So only one kind of mass available in this universe. So gravitational force is always attractive, not repulsive. And it is a mutual force. That means two objects attract each other with equal and opposite force. So you can say that it is a mutual force. That is, if object with mass m1 attract another object with mass m2, then this attraction force exerted by mass m1 on m2 is called action, and at the same time the object with mass m2 also attract the object with mass m1. This is called reaction. So action and reaction there takes place simultaneously. So gravitational force is a central force, that is, it acts along the line joining the center of the bodies, and it is a mass dependent and distance dependent force. That implies that if mass increases, force increases, and distance increases, force decreases, because it depends directly on mass and inversely on square of distance. Gravitational force obeys inverse square law. Inverse square law means that a force decreases as a square of distance. So it is inverse square law. It obeys inverse square law. It is a long range force that implies gravitational force act up to infinity. That means an object is much more away from the center of the earth. That means you can say that our sun is 15 crore kilometer away from our earth. Still our earth attracts the sun towards its center and sun attracts earth towards its center. So it is a long range force. It decreases with the distance as per inverse square law and becomes zero at infinity. That means if distance becomes infinitely large, then force of attraction becomes zero. Like electrostatics and magnetic force, it was also the same case that magnetic force and electrostatic force becomes zero at infinity. Now, gravitational force does not depend on the medium. It does not depend on the medium between the interacting bodies. There is no gravitational shielding. So, this is one of the remarkable properties of the gravitational force. Now, we have to describe universal gravitational constant, which is denoted by capital G. From the expression that we have derived here, F equal to G into M1 into M2 upon R square. So from here, we can calculate G equal to FR square divided by M1 into M2. So you see here the same expression. So this becomes when M1 and M2 is made to be 1 kg, that is mass of body M1 is also 1 kg and M2 is also 1 kg and distance R is also equal to 1 meter, then capital G becomes equal to F. That is 1 into 1 divided by and 1 divided by 1 into 1. So this becomes 1. That is capital G is nothing but equal to force. So in that situation, you can define gravitational constant as the gravitational force, that much gravitational force between the two objects when their masses is 1 kg and separated by a distance of 1 meter, then force of attraction between the two objects is nothing but equal to gravitational constant. So value of universal gravitational constant G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. The value of G does not depend on the medium between the two bodies. That's why it is called universal gravitational constant, and it will remain same anywhere in the universe, whether you go to the moon or go to the Mars or anywhere in the space. The value of capital G, that is universal gravitational constant, will remain same, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. That's why it is called universal gravitational constant. The value of Z does not depend on the medium between the two bodies. The value of Z is same throughout the universe and hence the name universal gravitational constant. Universal gravitational constant is different for the acceleration, different from the acceleration due to gravity G. So always remember that a small g and capital G represents two different things. So therefore, correct symbol must be used accordingly. SI unit of universal gravitational constant capital G is Newton meter square per kg square. On the other hand, SI unit of a small g is meter per second square, because small g represents acceleration due to gravity. Now, if two bodies of mass 1 kg each are separated by 1 meter from each other, then force of attraction between them is nothing but what? Universal gravitational constant. Therefore, universal gravitational constant G is numerically equal to the force of gravitation which exists between the two bodies of unit masses kept at a distance, kept at a distance of unity from each other. So now I think that few 5 minutes more we have to discuss. And here you see, gravitational force is the weakest force of all types of forces. There are three fundamental forces: gravitational force, electrical force, and nuclear force. So, out of these three fundamental force, gravitational force is the weakest force of all. If the two body of mass 1 kg each are separated by 1 meter from each other, then force of gravitation between them is 6.67 into 10 to the power minus 11 Newton. This is so a small force that you cannot realize it in real life. Though the various objects on the earth attract one another constantly, they do not cause any visible motion because gravitational force of attraction between them is very, very small. That's why it does not produce any types of motion. But when the same object is left or placed in the universe at a distance r, then the two objects will start moving towards each other, because in the space there is no friction or any hindering force. That's why the two objects will attract each other under the influence of gravitational force. Although it is weaker or weakest, yet they will attract, because no force is acting there in the space on the two objects except gravitational force. So object will attract each other under the influence of gravitational force, and hence will move towards each other, hence motion will be created in the space. But here on the surface of the earth, if two objects attract each other with a gravitational force, at the same time frictional force is acting there between the two, and any other force acting between them. That's why the two objects will not move under influence of gravitational force, because gravitational force is so weak. When both the objects are very big, when masses of object increases, uh, you can see that it becomes very big, massive, having very large masses. Then gravitational force of attraction between them becomes extremely large. Say, like mass of the earth, which is of the order of 10 to the power 24 kg, which is much more bigger. That's why gravitational force attracted by the earth is so extreme that we can realize in our daily life. And this force can produce motion. That is, an apple when falls from the branches of tree, it moves down under the influence of gravitational force of the earth. So gravitational force due to the earth on an object of mass 1 kg placed on the ground is 9.8 Newton. That is, when an object is there on the surface of the ground, it experiences if mass of the object is 1 kg, then it is experience 9.8 Newton force there onto the surface of the earth. But as we move the object away from the surface of the earth, the force will go on decreasing. So gravitational force between the earth and the moon, even at the large distance, is very large and is 2 into 10 to the power 22 newtons. This much the force between our earth and moon acting there. I think that this is enough for today's class. Next day, we will discuss Kepler's law, and notes of today's lecture will be uploaded on YouTube channel, and you will be notified. So till then, keep reviewing this lecture and think about that and draft notes according to this lecture. Thank you.